welcome to a tutorial. This is going to be the next in the series with the Firestore, and this one's going to be all about querying your Firestore database. So here's the lesson plan for what we're going to do. First, we're going to go over the query API and see what we're able to do, the different operators that we can use, and how we're going to query based on the fields. And then we're going to look at some limitations, because Firestore is actually quite limited in how you can query it, and you might find that there's so many limitations that NoSQL in this document storage isn't actually what you need to use or want to use for your data set. So you're going to have to think about that quite hard, whether these limitations matter a lot to you. Then we're going to look at composite indexes, which is a scary thing in SQL and stuff like that, indexes and getting them to work and making everything speedy. Firestore really just gives you a link to click on, and then you click on it and it makes index for you whenever you have a search that has sorting or complicated things going on. So it's really easy to make. We'll look at how we're going to do that. And then we're also going to look at ordering results, which is related to composite indexes. So let's say we wanted to sort by birthday or something like that, and then sort by another field to break ties. You're able to sort by multiple fields. Okay, so first let's go over the query API. So there's this document here with the Firebase website. They don't actually have Dart listed in here for the languages, but that's okay. What we really care about is just what we can do. So here is a complete set of things that we can do, and all of them are supported in Flutter. So the ones you can expect with like number fields and dates that you can use, less than or equal to, greater than or equal to. So if you had just a number, like a rating, like for a review of a restaurant or something like that, it keeps a total of the ratings. You could go, ratings greater than 3.5 or something like that. You could also do this with timestamps, so you can go, a date greater than a certain date. Then not equal to has some limitations on it. Well, actually, most of them have some sort of limitations, but we'll look at the limitations more in the next section. So array contains and array contains any. You are searching within an array in your document. So in the example that I have, I'm going to have a user, and they have a list of languages, and those are strings for the key for the language. So array contains, I would have my list of languages, and I'm going to say, do you contain this one value? And then array contains any is similar, except I'm going to pass a list of values. So if any of them are in the array, you're looking with a list of values in a list, then it'll match. And then in, it's similar, but you're going to search with an array, and you're going to search a single value. So let's say my document had a single string in it, and I pass in, say, I'm going to pass an array, and you say, is the one in my document in the array I passed? And then not in is the same, it's just the opposite, where it's not in the one that I passed. Let's look at the data that I got set up. So if you watched the last tutorial, we got a users collection with users, and I've added a new field to it, which is languages. This is the languages that the user speaks, and the codes come from just kind of standard codes for English, French Canadian, Chinese, and this one apparently has English on there twice. But anyways, it's just randomly generated data, so we can look at querying the arrays. Also now email can be null sometimes, so we can see what querying with null is like. And now some of the users are also randomly have a email verified of true. And we got a whole bunch of data now, so we can see it's a query actually returning certain stuff. So let's look at what it looks like in the actual Dart code. So in the users repository, we had this method last time that we skipped over, which was query. So query, I've made a class what a query is going to use, which is this users query. And I think making your queries into classes makes a lot of sense, so that you can kind of encapsulate the different fields that you're actually able to manipulate, and then handle it in a way where it's all like type safe with just these fields here. So we're going to have is email verified, and this is nullable. So the idea is if it's true, it's only users that are email verified. If it's false, it's only ones that are false. And if it's null, it doesn't look at this field whatsoever. So it'll return both. Date time born after. So this is going to be our greater than field that we're going to use, so that we can put in a date and say only users born after this date. We're going to use this language, so we're going to give it one language, and you say array contains, and we're going to make sure that that user has that language in their array. A language identifier is just basically a string. It's a type def that I made. And then sort direction, we can change the sort direction of the result so that it's either newest to oldest or oldest to newest based on birth date. So that's a query we're going to use. Let's now look at our users repository. So let's first read these limitations. So there is quite a few limitations to querying in Firestore compared to SQL or other data structures. So just based on this link here, summarizing that document, you cannot query with OR logic. You must split these into 2 queries and merge the results. So what this means is you cannot say, get me users that are born after 2005 or born before 1999 and have these 2 different data sets. That's not valid. You cannot do that. You would need to call your Firestore twice and get those 2 different result sets and then merge them in the client. And this is true for basically all OR logic, except for array contains any is a bit like OR, because you're basically saying, does it contain any of these values, which is a bit like OR because it's this one or this one or this one. Sorry, that's not going to work for every single use case, so you're going to have to make sure that if you need to use a lot of OR logic for searching, Firestore might not be best. You might want to look into using SQL instead. And the next thing is you can only do not equals, greater than or equal to, or less than logic on one field. So one real big deal breaker for this sort of thing that I ran into in the past is that, so let's say you have a document that has a rating, like a user generated rating, let's say it's stars 0 to 5, and then it has a rating count. So let's say you wanted to query and said, get me all the documents that are rated greater than 3 and at least 5 people have rated it. This is actually impossible, so you cannot do that. So what you would need to do is make the query twice with this one and then this one, and then merge the results and filter out any of the ones that didn't match both of those things in the client. And this is a bit of a hassle because it means 2 round trips if you do them one after the other. And also it's increasing the amount of reads that you're doing on your database quite a bit, because you're getting a whole bunch of results back that you don't actually care about. So you can see if you want to do a lot of OR logic or a lot of greater than or less than on many different fields, this Firebase document solution might not work for you whatsoever. Next is you can only use at most 1 array contains clause per query. Which that means is if I had multiple different arrays in my document and I wanted to say, okay, languages contains this one and this other array contains this, you can't do that either. Again, you would need to do 2 different queries and merge the results. And then similarly, you can use at most 1 in, not in, or array contains clause per query. We're not going to look at these as much because I think just array contains kind of covers the basic idea of how you're going to query arrays. But yeah, and then the 5th one is you cannot do string contains queries. This one is really bad for fuzzy searches. So let's say we wanted to get all the users where their name contains something that the user typed in. This is actually not possible at all. You can't do a fuzzy search based on strings. It's not possible at all. So what you would need to do is return basically all of your users and then do it on the client side. So this is not great because if your document, if you're expecting 10 results but you have 1 million documents, this is going to cost you 1 million reads when really you only care about 10 documents. So again, if that's a deal breaker for you, just think hard about this stuff when you're architecting. Is this really the solution that you want? If you have data that is suitable for this, well then that's actually great, because Firestore is not only really, really easy to use, it's also super fast. So one reason that it's fast and faster than SQL in some cases is because NoSQL, at least in Firestore, the speed of the query depends on the size of the result set instead of the size of the data set. So if anybody's worked with a SQL table with a couple million entries in a table, querying that can take really, really long time. Sometimes a crappy query that doesn't have the indexes sorted out properly can take minutes, right? But in Firestore, if you have 1 million documents and your result set is 10, it doesn't actually matter if you have 1 million or 100, it's going to take the same amount of time, which is really, really cool. I don't know exactly how that works internally, but just something to note. Okay, so let's look at the actual code for how we're going to use this where. So what we're going to do is take our collection reference, and we've built that up here. So the collection reference just comes off of our Firestore with the collection name, and from the last tutorial, we gave it this converter so that we know it uses a user model. And then we're just going to use this method .where. So .where takes in a field, and then it takes in one of these options for how you actually want to query. So you can see all of the options from that website are in here. And what we are going to do is just use our class, this user's query, and the keys from our model to query that collection. So this query, what we're saying is that the key where the languages live, that array must contain the language that we've selected in the query. And then you can chain these because each where also returns a query. So we can go .where again and say our birth date for our user must be greater than this date that we're passing in from the query. And remember that Firestore uses timestamps internally, so we got to go timestamp.fromDate to make this work properly, even though our code is going to be using date times because that's what Dart likes. So next up, this is how I'm handling this kind of tri-state thing with the Boolean. So if they've passed and is email verified, we're going to filter by that. We're going to look up that is email verified, and we're either going to make it equal to true or false. But if it's just null, we're just not going to stack this on at all. So see this query, it's just var, so we can reassign it. We can reassign it with this .where if we feel like it. So if they haven't passed this variable in with the query, then we're just not going to do this at all. So it'll return both true and false for is email verified. Okay, so next up, this is the order by. So first, let's just look at how the query is built, and we'll look at the order by later. So on the user screen, what we have is a button that queries users, and it's just going to build this query, and we're going to pass it into the block, and the block has a handler for handling that query. So we're just gonna, this is just hard-coded. The user on this screen can't actually select anything, but let's just look at what it's gonna do first. So is email verified is null, which means we're gonna get both true and false. Born after 1900, so it's gonna be pretty much every user. And language must contain English, and we're gonna sort by birth date descending. So let's see that in action. So we're gonna query users, and here we are. So we got both email verified true and false because we just said it was null. And then it's sorted descending. So this is born 2 days ago. And then we go down here to the bottom, and it's 1972. So that's working properly as well. And the the languages, each one is going to have English in its array there. Some of them apparently have it twice because my randomly generated data is dumb, but that's okay. So yeah, everything matches those queries there. So let's change it up a little bit. Let's just to show that it works. Let's do born after 2020. We'll do a hot reload and hit query again. And that replaced that entire list with only 2020. And let's go back to seeing more of them. And let's change this language to Chinese. And now we can see ZH. Okay, so let's go back to English, and let's just try out the ascending. And here we have one where it says this query requires an index. So whenever you change the sorting or change your queries, it's pretty likely that you're going to need a new index for Firestore to be able to execute that query. So I've got this error listener, and it just pops up an error dialog whenever there's an error. Let's look at that before we look at the index. So I have in my init state, I'm going to set up my query error listener, and here's an error stream subscription for the errors, and then in dispose we just got to remember to cancel that. So what we're going to do is just find that users block, get its stream. We're going to say we only care about this query users process, and we're going to map it to that, and then we're just going to call distinct, so it's only when that actually changes. And then we're just going to listen to that stream and show a dialog with the raw error whenever that happens. So let's look in the console because it's going to print in the console for me as well. And basically what it says is this query requires an index, and you can create it here. And all you got to do, literally all you got to do, is click this link, and it takes you to your indexes page, and then you click create index. You can, if you want, try to add these preemptively by going add index and do it for the collection and the field path and all these things. Or you can just go through your app and just click every single button and sort in every single way that you possibly can, such that every single index is built. So this is a bit weird because if you were to change your app and change your querying and just release it, that query might not be built yet. So users might be doing a valid query, but you don't have your index built. So you really got to make sure you're clicking around your app and making sure that every permutation of your query has an index. Because look at for this one, I actually need a whole bunch of different queries for the different descending and ascending sorting. So you really want to test out every single permutation. These do take a little while to build, so I'm just going to let that build, and we'll go back into the app. Okay, we'll clear the console as well. Oops. Okay, so we'll see that other sorting in a moment. Okay, so let's look at ordering results next. So ordering results, let's go to the users repository here. So your query has this method .where, and it also has this method order by. And what you can do is order your results. So if you limit the number of documents returned, like say I only want a max of 20, sorting matters a lot because it'll change which documents are returned, right? Because if you change the sorting, the first 20 in the list are going to be completely different. So what I've said here is if you pass the sort direction, we're going to sort it via that direction. So this the order by actually just wants a Boolean for whether it's descending or not. I kind of like the enum that I've made sort direction because it's a little more explicit whether it's ascending or descending, not just a Boolean. But anyways, if it's descending, then it's true, and then we pass it in there, and we're sorting by the birth date. And the other thing that you can do is stack order bys. So what it's going to do is it's going to sort by this field, and if they have the exact same birth date, which is a timestamp, so it would be exact to like the smallest increment of time possible, then it's going to break those ties via this field, right? So you can stack order by such that it sorts by one field. So first it's going to sort by birth date, and then it's going to break ties with another thing. So what I've done here is that it's going to order by the email verified, and with descending true, bools are a little bit weird. If we put descending true, it puts true above false. And then if it's descending false, it puts false above true. This is a bit confusing, but you can just experiment and it should be pretty easy to figure out. But let's look at our guys here. So see that right now, the way that I have it with descending true, everybody with email verified true with the exact same date is above those with the same date, but it's false. So first it's going to sort by that birth date. So 0 years old, and then 1 year old, and then true, 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 then this one's false, right? And then we go down, and so on and so forth. So when you add order bys, there's also a chance that you're going to need to add more indexes, and there's also a chance that you're going to order by something that it complains about and says you can't order by this field because you've used greater than or equal to on this other field, and sometimes you're going to run into these issues, and you're just going to either have to ignore being able to sort by that way or find a different way to do that. Like you can potentially just sort these things on the client side as well. Okay, let's see if that index is built yet. So let's go back to our user screen. So we change this to ascending. And now it's happy. So at the top of the list, we have 1972, and it flipped the order. So it looks good. And we didn't do is email verified only true or false yet, so let's do that as well. So doing this, looks like it just gets an error. Failed assertion, condition field not equal order field. We cannot use is email verified to be the same as your where field. Oh, well that's quite annoying. Maybe this field shouldn't exist at all. I might just delete it. So yeah, you're going to run into issues like this using Firestore because there's just a lot of different things that you can't do. So let's go back to the docs, and we're just going to Control F, you can't, and there's 9 of them on this page. So let's just read the you can't so we can try to sort them out in our heads. So you cannot combine not in and not equals in a compound query. Sure. You can't combine array contains with array contains any. You can't combine array contains, that's the same one. You can use at most one in, not in, or array contains any. You can't combine not in with not equals. You can't order your query by a field included in the equality or in clause. So this is, I believe, the one that I just violated here. We can't order it by email verified because we're also checking the equality of it. So right now my query is in a way that's actually impossible, so maybe we should just go fix that. Oops. And I think that just being able to query by this doesn't make any sense because this is kind of invalid with the sorting that I've given it. So let's just delete it. Okay. So you can see that you're going to run into issues like this with Firestore, and it's quite annoying sometimes. But it's just so fast and so easy to use that I think it's usually worth it. And also, if you have pretty simple data that you don't need to like search, then it's fantastic. So one thing that it would be really good for is something like a chat messages, right? Because you're not going to go chat messages where something. You're just going to go give me all the chats from this timestamp onwards, and maybe you're going to paginate it or something like that. But you're probably not going to go, find me all the chat messages where there's some string contains like that. That's not usually a chat feature. Okay, yeah, so I think that about wraps it up. Yeah, thanks for watching.